Today we're going to learn how to solve literal equations, and it's just building off of what we've learned in our previous lessons. We're going to use inverse operations to eliminate the things that we want to eliminate so that we can isolate what we want to isolate. The only difference is now instead of getting something like x equals some number, right, we're going to get something that has a little bit has more variables than just the one that you're trying to solve for. A great way of thinking about literal equations is this last bullet point, which is essentially saying that you're going to take an equation with lots of letters and solve for the letter in particular that it's asking you to solve for. So in this case, in this first example, we're solving for B, but you can see that there's multiple letters. Don't let the letters confuse you. You're still doing the same exact thing that you do if they were numbers, which is just inverse operations. And I'm going to write this real quickly, this idea of SAD MEP, which kind of helps us figure out what we need to eliminate first. We're going to start here, these two, and we're going to eliminate our division and multiplication. Then we're going to eliminate our exponent. Finally, we're going to eliminate our parentheses. And because this is being all of these terms are being divided by 3, I can actually put it in parentheses, and it'll help me make this solving this equation a little bit easier. Multiplication or division comes before parentheses in reverse PEMDAS. So if I want to eliminate something that's being divided, I'm going to multiply, and since I want to eliminate a 3, I'm going to multiply by 3. I'm just going to write it as a fraction because this looks like a fraction. Whatever I do to one side, I've got to make sure that I do to the other side. I don't have to write it as a fraction over here because this isn't expressed as a fraction. I'm going to simplify my left side. 3 divided by 3 is 3. A plus B plus C divided by 1 can just be written as A plus B plus C. You might have known that I switched the equation around. I mean, I flipped the sides. You can do that as long as you don't change any of the signs or add anything new. A times 3 is the same thing as 3A, and we're going to write our multiplication without any operating signs or parentheses in our answer box at the end. Now I need to eliminate A and C, and since they're both being added, it doesn't matter which one I eliminate first, so I'm going to eliminate this A first. I need to eliminate this A by subtracting, or another way of thinking about subtracting is adding a negative. I like to think about it as adding the opposite, because if I know I add the opposite, when I add those two together, it's going to simplify to 0, and if it's 0, then that means it's gone. So I'm left with B plus C. Well, if I add a negative A over there, I've got to add a negative A over here, which is the same thing as, like I just said, subtraction. So I can just write this as 3A minus A. And now I've got to eliminate the C. Well, I'm going to do that the same exact way I just eliminated the A. I'm going to add the opposite of C, which is, can't write a C. Come on, mate. Which is adding a negative C, because I know that these two, when simplified together, go to 0. So I'll just left with B. Well, if I add a negative C over there, I'm just going to write a subtraction right now. I'm going to subtract or add a negative C to this side. Since none of these are like terms, I've got to make sure that I write my final answer in order that the terms come in the alphabet. So since A and A are the same exact letter, I'm going to actually write the capital one first, then the lowercase, and C comes after A in the alphabet. So I'm going to type in my answer like that. I don't need to include any parentheses or anything. Question number 2, 7x minus y equals 14. I'm solving for x. So what I've got to do is I've got to eliminate this y and the 7. Since the y is being subtracted, you eliminate subtraction by adding, or you can just think about adding the opposite number. In this case, adding the opposite. So the opposite of a negative y is a positive y, because when you simplify those together, they go to 0. If I add y to one side, I got to add it to the other side. On my left side, I have 7x equals 14 plus y. I'm actually going to commute this y in front of this 14 because in my answer box, it's going to ask me to put my answers in standard form, and variables always come before numbers or constants. Notice that I didn't change the sign of either of these terms. As long as I keep the sign with it, I can put them in whatever order I want. Now I've got 7x equals y plus 14. I've got to get rid of the 7. There's not an operating sign between them, so I know it's multiplication. Inverse of multiplication is division. I want to eliminate 7, so I divide by 7. And make sure that I divide this entire side by 7. So I'm going to divide the entire side by 7. Now I have x equals y divided by 7 can't be simplified, so it's just y y divided by 7, sorry, plus 14 divided by 7 is just 2, and I'm actually not going to do anything to my answer when I type it in. I can just type it in as y divided by 7 plus 2. Sorry if I'm going a little fast. We got to get through 10, so I'll try to slow down if I have time. V plus t minus 16t squared equals h. I've got to solve for v. What I'm going to do here is eliminate subtraction, because subtraction comes before multiplication. If I want to eliminate a negative 16t squared, all I have to do is add the opposite, which would be a positive 16t squared. Make sure that I add it to both sides. I know that these are going to go to 0 because when you add the opposites, they simplify to 0. That's the additive inverse. And what's left is vt and h plus 16t squared. And notice that these terms are in alphabetical order right now. Now I've got to eliminate this t. Since it's being multiplied, I'm going to divide. And in the last example, I divided each of them by t separately. But in this example, I'm just going to divide the entire side by t like this, because I realize that I can't really simplify these like I could the 14 and the 7. So when I write my final answer, I'm going to write it as, not y, I'm going to write it as v equals h plus 16t squared. And just like we do at the beginning, since they're both being divided by the same value, I'm going to put it in parentheses. This will help the computer distinguish my order of operations, and I'm just going to put it over t like that. Alright, question number 4. A equals h times b plus c. I'm solving for b, so I've got to eliminate h and I've got to eliminate c using inverse operations. Well, parentheses comes after multiplication, so I'm going to eliminate my multiplication by dividing. Since I want to eliminate h, I'm going to divide by h, do to both sides, keep those scales even. Can't forget those scales, man. A divided by h equals, and we know that these are going to divide to 1, so we can just write this as b plus c, because we know that this times 1 is just b plus c. Now I've got to eliminate the c. Well, it's being added. In order to eliminate a positive c, all I just need to do is add the opposite. If I'm throwing you off with that, just write it as subtraction, okay? C minus c is 0. I'm going to write it as a plus and negative because I don't have enough room to write minus c right there. And then I'm going to actually write this side of the equation on my left side now. So I've got b, because c minus or plus a negative c is 0, equals negative c plus ah. I'm going to commute my ah in front of my negative c because a comes before c in the alphabet. So I've got a, whoops, it's capital, my bad, make sure you include the capital because it's case sensitive, a divided by h, and it's a minus c, so I can just write it as a minus c, no parentheses. Okay, here we have 2 times L plus W equals A. I'm solving for L, so I've got to eliminate the 2 and the W. Multiplication comes before parentheses and reverse PEMDAS, so I'm going to divide to get rid of this multiplication. I want to divide by 2 to get rid of the 2. Do both sides. Hopefully this is becoming a little bit more fluid to you guys the more you use inverse operations. Equals A divided by 2. Now I've got to eliminate the W since it's being added. I've got to subtract or add the opposite. This go to 0. Subtract it on this side. I don't need to add a negative here. I can just write a subtraction. L equals, and if you don't believe me that adding a negative and subtracting are the same, think about this example. I've written this on the board several times. These two things, 1 minus 1 equals 0. 1 plus a negative 1 also equals 0. These concepts are identical. I'm stuck with A, sorry for the tangent, divided by 2 minus W. And I can actually put my answer in like this because A comes before W in the alphabet. Here we have y equals mx plus b, and I just flip the sides of the equation because I know at the end I need to have b on my left side. So I've already put b on my left side, so I just rotated my scales. Didn't change anything. I'm going to solve for b, so I've got to eliminate this mx. Since it's being added to this b, I can subtract mx from the side or just add a negative mx. Well, if I add a negative mx on this side, I've also got to do the same thing here. And not to confuse you, this is subtraction. B equals y minus mx. I've got b by itself. It was a one step, but These are not in alphabetical order, so I just got to use the commutative property real quick, and I'm going to commute the m in front of the y because m comes before y, so I can rewrite this as b equals, it was a negative, still is, and it was a positive, still is. Okay, awesome. Here I have negative 5, y equals negative x minus 15, and I'm solving for y, so I've got to get rid of this negative 5 since I know these are connected through multiplication. I'm going to divide because that's the inverse, and I want to divide by negative 5 so I can eliminate this negative 5. Do the same thing, and I'm going to write it like this time because I know already that I'm going to be able to simplify one of these two terms when I divide it by negative 5. So here I have negative 5 divided by negative 5, which is just leaves me with a 1 times y, which is y. Negative x divided by negative 5. Well, I know that a negative divided by a negative is a positive, so I can rewrite this as just x over 5, right? And same thing here. I've got a negative divided by negative, so I know it's going to be some positive. And 5 divided by 5 is just 3. And that's how I'm going to type in my answer. No parentheses or nothing. Video skip. Okay, we just did question 8, or question 7, now we're on to question 8. Here I have r equals L plus 3w all divided by 2, and I'm solving for w. Real quickly, I'm just going to write it like this, equals r, and I'm going to throw this in parentheses because they're both being divided by this 2. Division comes before parentheses, so I'm going to multiply to get rid of the division, and I'm going to multiply by 2 to get rid of the 2 that's being divided. Do it to both sides, keep those scales even. I'm left with L plus 3w equals, and r times 2 is just 2r. Now I want to eliminate this L because it's being added and addition is easier to eliminate than multiplication, so I'm going to subtract an L, and I'll fit it in this time for those of you guys who are freaking out about adding a negative. Minus L, I know that L minus L is going to simplify to 0. I'm left with 3w equals 2r minus this lowercase l. Now I've got to get rid of the 3 what's being multiplied, so I divide, and I'm going to divide this entire side by 3 just like this instead of individually because I'm not going to be able to really simplify anything. And I'm going to write my final answer as w equals 2r minus l, and since they're both being divided by the same value, I'm going to throw it in parentheses so the computer understands that I'm doing this before I divide by 3. Okay, here we have a equals x plus y divided by 2. Very similar to the last example. I've got x plus y, which is being divided by 2, so I'm going to throw it in parentheses, and a. And I'm writing it on the side because I know at the end I'm going to need my y on my left side anyway, so it doesn't really matter. But here I'm going to multiply again by 2 to eliminate this 2, and since it's being divided, I need to multiply to invert it. I'm going to do it to both sides. 2 divided by 2 is 1. X plus y divided by 1 is just x plus y. And a times 2 can be rewritten as 2a. Here I need to get rid of this x since it's being added. Back to adding my negative, right? I'm bouncing back and forth between the two ideas, but you already know that they're the same. So if I add a negative here, adding a negative is the same thing as just subtracting. So I'm going to represent a subtraction over here. Save myself 2 seconds. 2a minus x. Since it's in alphabetical order, I'm just going to go ahead and type this in the way it is. Alright, last example. We've got about 40 seconds before this thing times out on us, so I'm going to go fairly quick. I've got negative 50 minus 10y equals 6x, and I'm solving for y. It's easier to eliminate this negative 50 before this negative 10 because negative 50 is being subtracted, so I'm going to add the opposite of negative 50 was positive 50. I'm going to add it here. I've got about 30 seconds left. These are going to eliminate to 0, but we already knew that, so what's left on this left side is just a negative 10y equals. These are not like terms, and they're already in standard form, so I don't need to do anything here. And now my last step is to divide by negative 10. I'm actually going to do this individually now because I know that one of these is going to be able to be simplified, so I'm left with y equals. I'm not going to simplify this. I'm just going to write it as negative 6x plus 10, and 50 divided by negative